graph 1/2 times the tangent of x. So for our tangent functions, there's 3 steps that we're going to follow. First is getting the x-intercept on our graph. So the x-intercept will be at the origin. So there's our starting point. The next thing we need are those vertical asymptotes. And we find the vertical asymptotes by doing pi divided by 2b. Our b value is what number is in front of the x, which in this case is just a 1. So pi over 2 times 1, or just pi over 2. So I go to where pi over 2 is. It's going to be halfway between 0 and pi. And there's an asymptote. Now, the asymptotes fall on the odd multiples of this pi over 2. So I can go to the left pi over 2, and my first cycle is going to fit within those 2 asymptotes. So now the last thing that we're going to do is those halfway points, and that's what we use our a value for, which in this case is the 1/2. So we're going to use plus and minus 1/2 values. So the way that we do this is we start at the x-intercept, and I'm going to go halfway to the asymptote on the left. So I go halfway to the left, and then down 1/2, which puts me right here. And then I go back to my intercept. I go halfway to the right and up to a positive 1/2. And now I have my 3 points. I'm just going to come in on the right, hugging that asymptote, come in for these 3 points, and then back to the asymptote down that way. So that 1/2 out front, what that actually changes for us is kind of the curviness of this graph, or how steep that curve might be. As you get smaller numbers, you can see that this is getting a little bit curvier. So I can do another cycle. This graph I can see has a period of pi. So if I go over another distance of pi, which on this graph is 4 sections, I can fit another cycle in here. So the intercept goes in the middle, and then we need our halfway point. So we go halfway to the left and down 1/2, halfway to the right and up 1/2. And you can see I'm getting the same graph as the left. Now there's just 2 of them. So there's our tangent function, just following steps 1, 2, and 3, and then we have our graph.